So in our next section, like I mentioned, we're going to go over a brief introduction of iOS XR. I'm not going to go through all of the features because as we go through class throughout the week and we go through the IGPs, BGP, MPLS, we're going to be looking at the configuration both on regular iOS and on XR side by side. But what I want to do here first is just for those of you that aren't really that familiar with the interface, I'm going to go over some of the main functional differences between regular iOS and XR. So here we see the command line. One of the first notable differences from regular iOS to XR is that it always asks you for login authentication and exec authorization. So there's always going to be a default username that you have to configure when you do the initial upgrade from regular iOS to XR, or like out of the box if it's CRS or ASR, it's going to have some sort of admin login. Okay, so we log in to the box here. Next thing that's going to be different is that there is a separate administration mode that is going to be used to control the actual hardware of the chassis, or in multiple chassis systems, that is what's called the designated shelf controller that can control multiple physical racks in the data center. So to get to this, you type admin. That's going to go into the admin mode. In the lab exam, if you type admin, most likely it's going to say that that's not authorized because they don't want you changing like the hardware allocation of the actual box. From here, if we look at the show run, the only thing that I have in here so far is just a default username and password. The key is that this particular user is in the group that is root-system. It means that they're allowed to go into the particular admin mode. Now, right now, if we were to look at the show diag summary, this is going to show what are the particular line cards that the platform has. In this case, there's two PRPs, which is the route processor, basically the general purpose CPU, and then there's four specific line cards. There's two 4-port GigE cards, and then there's two 1-port OC48s. Okay, there's also on this particular platform on the 12,000, this is a 12,008, so it uses what's known as the clock scheduler card. It's basically that allows you admittance to the fabric to control like how the packets are actually routed on the backplane. And then the fabric cards, this is like the actual backplane, the actual fabric that controls how much bandwidth the backplane has. From here, if we were to look at the detail of show diag, if you're running into a hardware problem on any of these platforms and for some reason any of your line cards are not actually showing up, what you want to look at here is what is the state of the card. Now, some of the other ones, like the switch fabric cards or just the clock scheduler card, these don't actually run iOS XR. They're just like used for, like I said, controlling whether packets are admitted to the fabric or the backplane. Their state should be in powered state. Basically, just means that the card is on and nothing is broken with them. The actual line cards, whether it's the route processor, which in this case these are PRP2s, the state should say that it is in iOS-XR run. Basically, anything besides this means that there's a problem with the card. It could be that the card is like in reset if you manually reboot the card. If it just says that the state is powered, it means that at least you can plug the card in and the lights are going to come up, but it's not actually talking to the fabric for some reason. So if we were to say show diag and include just the state, ideally I want to see that my 6 line cards, which are the 2 PRPs and then the 4 actual cards, so the 2 GigEs and then 2 OC48s, all of these that their states should be in run, iOS XR run. So it looks like this particular card is in bring down. This means that it's currently being reset. One thing that's different. Go ahead, question.
You can do show platform, no?
You could do this as well, yeah. So this one, actually I believe this is normal right now because this is configured basically as the backup PRP because this one is active. I'm sorry?
updated an MBI bus error on the log.
Slot 3, fabric is down, reloading. This may be, once I assign it to the other SDR, it should be fine. This hardware, since it's 12,008, is a little bit older. Basically, if you don't get to this state, there's really not much you can do. It's pretty much you have to just RMA the card in order to fix it. So in the actual exam, whether they have multiple physical chassis or they have virtual routers in a single chassis, it's going to be controlled from this admin mode. Now, the way that I have the rest of the rental rack set up is that there is a SDR, which is the secure domain router. It's basically a virtual router as part of the physical chassis. So the SDR has a name. I'll call this one XR2. And then from here, you allocate what particular line cards are going to be assigned to this router. So the location is talking about the basically like the slot numbering. In this case, these are cards 0, 3, 0, 4, and 0, 7 that I'm going to assign to this particular SDR. The end result of it is going to look like this, where XR1 has the PRP in the first slot, and then the Gigi card in the second slot, which is numbered 1, because it starts from 0. Then XR2 is allocated a PRP, a Gigi card, and then also the POS cards. Okay, unfortunately, what you cannot do is allocate the individual ports of the cards to different SDRs. So it's the full line card or nothing. So like if you have a SIP SPOD card, you cannot say that this particular SIP is going to that SDR. It's going to be the full line card. Okay, so I want to say here that 0, 3, star, 0, 4, and 7 are going to be allocated to that particular card. Now, next main difference we're going to see is that anytime you make a configuration change, it doesn't automatically apply in iOS XR. So if I hit Control-Z or if I hit End, it's going to say, do I actually want to apply these changes, or essentially, do I want to commit the changes? So I could have manually typed commit, which would have saved, or since I typed End, I can type yes. That's going to do the same thing as running the commit. So now it's going to reboot these cards and then assign them to the second XR here. Okay, basically this is the console that's going to the second PRP that's in that chassis. So before that, it said that this distributed route processor node is not ready for active login. This is because it was the backup PRP for the first one. So if you wanted multiple routers in the chassis but also redundancy, you would need the primary processor, the backup, and then for the other SDRs, likewise, you would need a pair of PRPs for each router that you want redundancy for.
Brian, we want to highlight, can you do that for regular PRP, or does it have to be a DRP to do SDR?
That just has to be a PRP2.
Yeah.
I believe it just has to be PRP2.
Okay.
Yeah.
Because on CRS, you have to do it with the DRP.
That's because of the CRS system.
Right.
That's specific to the CRS.
Yeah, it's a little bit different in the hardware.
ASR
Yeah.
is different too, right?
Yeah.
ASR, you
Yeah,
can
they don't-
allocate any of the
You're right.
interfaces
They
with
don't-
location.
For sure.
Right. Yeah. Okay. So eventually, once it boots, then it should allow me to log in here. So the problem with this, though, really the platform is not meant to be rebooted to begin with. So like if you power it off and power it back on, it literally takes about 45 minutes for the platform to fully boot. So I'm going to leave this alone and then go to a different rack that I have that has the cards that are fully booted here. Okay, so these ones now, when I connect to the console, it's just going to look like a physically separate router. So this is the normal global configuration mode. Depending on what particular user that I'm logged in as, I may or may not have access to the admin mode. In this case, let me see, can I say who am I? No. Let's say show run. I am logged in as the username XR2. They are the root user, but specifically for this particular logical router. So they don't have access to allocate what are the different line cards. This would normally be like your admin operator, but you don't want them changing the physical configuration of how the shelf is actually set up. Now, as kind of a side note of this, when you're using the equipment in the lab, if you accidentally delete the config, this local user is going to go away. And the easiest way to delete the config is from global config is to say commit replace. Basically, this says take whatever changes that I made in global config and then overwrite them to whatever the running config is. So if I say yes now, it's essentially deleting everything. This is the same as saying write, erase, and reload, except I don't have to reboot all of the line cards. Okay, now when I show run, basically nothing is going to be in the running config. Okay, this is fine, but the issue is now if I exit out of the console, there's no local user that is allowed to log into this SDR. So typically what you would have is in a real design, it's normally going to be through AAA, that you have some user that you're talking to like TACAX or Radius with to do the authentication. But if I were to log in here as the admin user, in my case it's XR admin, and go to admin mode, this command here, it says AAA authentication login remote local. This means for other SDRs in the chassis or in the shelf system, they can use these logins here in order to get locally to their consoles. For anyone who is not basically the owner SDR, where the owner SDR is like the main one where you're doing all the configuration from, anytime that you log in from this, you would have to add the @admin after the username. So username is xradmin @admin. So now I'm logged in as the root system, which is different than just the local username for that particular SDR. So now I could make a change, like if I were to say username xr2 password Cisco, and then commit this change. Now when I log out, now the user is recreated, so I can get back to them. Now when you're using the rental racks, if you do this and accidentally lock yourself out, you're not going to have access to this user because this is the one that our scripting system uses, like just to manage and reset the racks. What you can do though is when you log in through regular telnet, you're going to get a menu that shows up to connect to the consoles of the different routers. But there's also this option to do password recovery. Basically, this is a script that's going to go in and then add that particular username back in. So if you do lock yourself out, I set it up so that you can do automatic recovery for it.
Thank you. There's other racks that you can't do that.
That would be a problem. Yeah, yeah. Okay, so if you do commit replace, don't worry about it. You can always revert it without having to like submit a support ticket or anything like that. But the scripting system, the way that we designed it is that normally it will have the local username in there, and then there's a banner that says like use this default login in order to get there. Otherwise, you're not going to log in without that root system login. Question? So physically, like if we were to look at the chassis, and let me pull up a picture of it here.
It is still one chassis.
It's still one chassis, right? It's one physical chassis, but then inside of it there's 2 PRPs and then 4 line cards. So they're sharing the same backplane, but from our interface they look like different physical routers.
But you have to physically cable them together?
Yes. Yeah. So they're like the SONET interfaces. Those are cabled back to back between the routers.
It's like a VDC.
Basically, yeah.
So brand recovery script doesn't affect the...
It doesn't affect the rest of the config. So the only thing it does is just log in and adds the user and then logs out, so you can get back into it. So I'm not sure where the
Would you mind showing us the configuration
pictures. Yeah. Okay, so this is what the chassis looks like. So these are the 4-port gig cards. Or no, is that the? That's the PRP. These are the management ports, and then the console and the aux port. So basically, you have two separate console cables, one to one and one to the other. Then once you configure this, the second one is an SDR. They're treated as independent routers. By default, they're all part of the same router. So the second one normally is going to be a backup of the first card, that if the first card goes down, then the second one is going to take over for it. So it's like nonstop forwarding, like stateful switchover does it automatically.
What's your second PRP kit?
This one here. So the first one is in slot 0.
Oh, yeah, okay.
Second one there is in slot 1. These are the clocking cards. And then this one, I think, or no, so those are the OC48s right there. So if we look at the full config of the first one, this is the only thing you need to do just to specify what the other virtual routers are. But the key is that this 03, this is the PRP. You can't allocate a new router without a physical route processor to be able to handle it. Okay, so when we're not in admin mode, if I were to look at the show diag summary, they're only going to see the specific hardware that is dedicated to them. So this first router, XR1, is considered the owner SDR. It's the default one. And I have cards 0, 1, and 6 allocated to it. So like when I show IP interface brief, it's only going to show those particular cards. Okay, the management interfaces, these are part of the PRP. They're normal Ethernet links like you would use for Telnet or SSH into the box. Then these are the 4-port gig cards, and then the packet over SONET link. Same thing is going to be true on the other one. When we show IP interface brief, this command is not authorized. This does anybody know why this error came up here?
Don't you have to create your user with the administration?
I created the user, but I didn't authorize them to run the exec process. So what I needed to do was under the username, I have to put them in the proper group. Okay, the group is, I want them in the root group for that particular logical routers, root-LR. So now I would have to go in through admin again, xradmin @admin, and say, let's show run. So username xr2 is in the group root. Okay, so this is going to be the most privileged user of the logical router of the SDR. Then these other ones are sub-users that can run show commands but can't make changes. And then you can also define your own groups. This would be like if you wanted to do TACX, like command authorization, and create different groups to say these particular users can run these show commands but not other ones. Then you have the option to do that here.
So, I'm sorry for asking, but there's a group called root-system, right? And then, so you can't assign root-system to the actual guy that's in?
Not to the SDR.
Not to the SDR.
Yeah, so root system is under only the admin mode.
Okay.
Yeah.
I was told that you can configure NetFlow only on the admin mode, or that the NetFlow is part of the admin mode, something like that.
Well, what it may be referring to is to turn the software package on. So we'll look at the config of NetFlow, but if we go back to the admin mode, the other thing that you would want to do here is if you look at the show install active, this tells you what software packages the individual line cards are running. So typically the only case that you would not activate every single package on every single card is if you don't have enough resources on the card. So in this particular case, basically the cards have maximum memory, as does the PRP, so it's not really going to make a difference. But if I was not running multicast, then there's really no reason for me to turn this feature on, because I might be introducing multicast bugs, possibly with other features, and then you kind of like isolate the software from different components of it. But in this case, if we look at, it says that there's the owner SDR, which is the first PRP, which is node 00 CPU 0. Basically, everything is turned on here. And I want to say, I want to say that NetFlow would be under diags, but I'm not 100% sure.
I think it's under that MGB.
Yeah.
That's the
Management.
manageability.
Yeah.
Show install. The other one that you would want to look at here is show install inactive. This would be for some reason you downloaded the software but didn't turn it on the specific line card. And what could be a common mistake of this, so you download all the software like through TFTP to the admin mode. Then you have to actually install it, which is to say install, and then whatever the particular file is, you would say install, activate, and then whatever the package is. Normally it's going to show up here, but in this case everything is already running, so it doesn't show it. But once you install it, if you don't actually commit your changes, then it discards them when you exit out of admin mode. So you would have to say install commit once it's actually fully done. So the idea behind this is that you can do the software upgrade in service without having to like schedule a maintenance window. Then if something goes wrong, it's not actually activated until you do the final commit once you're done with it. But if you see for some reason you're working on one of these platforms and a command is missing, like you type MPLS LDP and it says unrecognized command, it would mean that that particular software package is not activated on the card. And it could get a little bit finicky because I could theoretically say that MPLS is activated on this card, but not on this card when you selectively do the install. I could say install it just on node 01 and not on 06. But assuming you want all features everywhere, you just activate every single package on every single card. I'm sorry? Probably not, because in the lab exam, I doubt that they're going to give you admin access.
Yeah, you only have access to
to the
your
individual
SDR.
SDR. Yeah,
You're not
yeah. But just from a practical point of view, if you're doing a new install for this, and you see that it doesn't run the feature that you need, then that's what you need to look at, is in the admin mode, is the actual package on. Okay, beyond that, there's not really much that you need to do in the admin mode. You do like the initial install, like if you're going from regular iOS to XR, that would be done under the admin mode. Then defining the SDRs and then activating the packages.
How are you changing between your SDRs right now? How are you going from your admin to your...
Just exit it, just leaves admin mode, yeah. If I exit now, it should have said, I'm not sure if I made any changes here, but it would have said that the user was XR admin, which is the one that's under root system. So like you said, this particular group is not under the SDR because that's authorization for the admin mode.
And then how did you change your root to the root system itself? I'm sorry.
How do I log into the admin mode?
How did you actually log into it?
So you just come in through the console or through like SSH. If you're on the owner SDR, which is this one, I would just type the username.
Gotcha. We're not going to have access to that.
You're not going to have access to this, yeah. So then from here, if I say admin, since I'm in root system, it allows me to do that. Okay, from the non-owner SDRs, you would have to log in as whatever the admin username is and then @admin. Okay, from here, then you could go to admin mode, and it's doing the same thing. It's just that I'm connecting from the non-owner SDR. Okay, but within the scope of the lab exam, you're not going to have to worry about that. It's just a kind of side note. If you are doing new installs of this, that you need to make sure that from the admin mode, everything is set up correctly first, and that the line cards are allocated to however you want to divide the chassis or the shelf system. Okay, the next thing that's going to be different from the regular like exec mode or the global config mode, when we look at show run, and actually let me revert this back to its defaults. I'm going to say commit replace. So that's deleting all the config. And if we now look at the show run, there's basically nothing in the initial configuration. Where when we look at regular iOS, if I were to say on any of the regular platforms, even when you don't have things like IP addresses assigned or other features here like we're doing .1Q trunking, at least you're going to see the physical interfaces and some of the default values. But in the case of iOS XR, there essentially is no default configuration for anything. So anything that you want to implement, you're turning all of those features on. So if I look at the show IP interface brief, the cards are allocated to the router, but they're not actually configured yet. That's why they don't show up in the initial config. Okay, a lot of the other features that you would normally take for granted, like CDP, for example, is not on by default. So what you may want to do is turn CDP on, then at the actual line cards, also turn CDP on. Then I could figure out what's going on in the actual physical topology.
So if you globally turn on CDP, it doesn't globally turn onto the interface?
Correct. So, and some features you'll see like this where you have to just turn the feature on to start. Then you go under the specific interface config or this different sub-configuration mode and then actually enable the feature on a per port basis. Okay, so now these changes that I made, turning CDP on and then enabling it on the link, it's not in yet the active running config. So if we look at the show run, you'll see that nothing has actually changed yet. If we look at the show config, these are my uncommitted changes. Basically means that they're configuration changes I made, but they didn't actually apply yet to the running config. So this is going to be most useful when you're making a config change and then you try to commit it, and it says for some reason one of your commands failed. So if you say show config, you're going to know just what are those particular changes that I tried to make for that individual commit. So now if I want to apply this, I have two options. I could either type commit, or I could type exit or end, and then it's going to ask me, do you want to commit these changes before exiting? Okay, so now the changes are made. If we look at the show run, now we see that CDP is on those particular links, and it's on globally. Okay, also I want to add a host name here just so I can tell them apart. I'll say this is XR1. And I'll add that username in there just so I don't have to keep using the admin login. I'll say username XR1. Password is Cisco, and the group is root-LR. On the other router, I'm going to do the same thing, except the interface numbering is going to be a little bit different. So on XR2, different host name, and then these are different port numbers. Oops. Once you get used to it, it's actually a lot better than iOS in a lot of different ways.
So is this just going to be limited to like the 12,000 series?
No, it's on our ASRs.
ASRs and the CRS.
It'll have feature parity. It'll be the same as in the next couple of roads here.
Or if you're used to Juniper, JunoOS.
CRS.
It's not going to get as close as that?
No, 7600 can't run it.
That's what.
Never, ever.
Okay, so right now you can see there's not that much config that I've added. Just turn CDP on. Now CDP are on the links. I also have this username to make sure I don't lock myself out. Okay, if we show CDP neighbors, I have the other XR, which is connected back to back. So if we look at the wiring, that's talking about these two ports here. Then also on the packet over SONET interface, it should be running. Okay, really for the sonnet links, there's nothing fancy about this. They're just regular serial interfaces, except they're much higher speed than you would have like your WIC1T or WIC2T on the regular routers. So if I were to say like show interface POS 0700, its bandwidth is 2.5 gigs, so it's OC48. The encapsulation is HDLC. The CRC is normally going to be 32 bits. Normally you wouldn't change this. It's that on higher speed links, you need a larger error check. Otherwise you could miss some of the errors in the frames and then they would get discarded. So basically every single frame that comes in, the card is doing the error check to make sure that the transmission was fine. But beyond this, it's going to behave just like a normal serial interface. So if we look at the config of it, right now the only thing that's running there is CDP. And let's say that we have just a basic back-to-back configuration between them. So we have XR1 to XR2. This side is POS 0600. This is POS 0700. Okay, we'll say the IP subnet is just going to be the 10 network / 24. We'll say this guy is .1, this guy is .2. Okay, so at the link level, a lot of the syntax is very similar to regular iOS, where I could say like the IP address is 10.0.0.1/24. I could also be a little bit more specific of this. It does give you some backwards compatibility from the regular iOS syntax, where the full completion of the syntax would be the IPv4 address. And then what's a nice shortcut, you can just say /24 or /31, whatever you have. Now when I show config, in the running config, it's still going to show up as the dotted decimal format. But configuration-wise, it's a little bit easier just to enter it this way than to figure out all your, whatever your weird, like discontiguous masks are. Okay, so if I end, it's going to ask me, do I want to commit? Yes, I do. On the other one, I could just say commit. That's going to do it manually for me. Okay, so now I should just have basic connectivity to the other side, which I do. So really nothing too complicated about this config. Just the link is up. It doesn't have to be running CDP. This is just for, check that the port is working. Then it's running IP version 4. If we wanted to run IPv6, the syntax is going to be similar. So on the interface, we'll say the IPv6 address, and then whatever address we want to use. Same thing on the other side. Yes?
Do we need IPv6 enabled, or that's
As soon as you turn an address on, it turns the routing process on globally.
Well, that would be with the XR.
Right.
For the iOS, we have to do the unicast routing.
Correct. For regular iOS, if you're running IPv6 routing, you need to say IPv6 unicast routing. Okay, because the default is already IP routing for version 4. For version 6, you have to turn it on. Okay, this can be kind of confusing because it allows you to configure addresses. It even allows you to configure routing protocols, but the process doesn't initialize until you say IPv6 unicast routing. But in iOS XR, you don't have to do that. As soon as you turn an address on, then it's going to start the routing process. IPv6 address. Okay, so now I should be able to ping the other end with IPv6, which I can. Okay, now when we want to do the verification, there's a fundamental change in the hierarchy of how the verification syntax works in XR versus regular iOS. And once you get used to it, it makes more sense the way that the commands are ordered. So instead of saying show IP route or show IPv6 route, some of these will be in there for backwards compatibility, but things like show IPBGP, you don't want to use the normal hierarchy of the iOS syntax. Instead, what I'm saying is that I want to check the routing table. What's the particular address family identifier and the sub-address family identifier? Like, am I talking about the IPv4 multicast routing table, or am I talking about just the IPv4 unicast routing table? So show route IPv4 would then be the equivalent of show IP route. Okay, likewise for v6, this would be show route IPv6. Like show route IPv6, show route IPv6 connected, show IPv6 route RIP, whatever the particular protocols are.
If you just did a show route,
Show route is going to show, I believe this is going to show just the global IPv4 table, which it does. Okay, also when we get into BGP, especially with MPLS, it can get kind of confusing what the order of the syntax is. Where on the routers we would say something like show IPBGP, VPNv4, unicast all, or VPNv4 all. You could also say show BGP, VPNv4, unicast. For XR, this is going to be similar to that second syntax. So show BGP, what's the main address family identifier, which is VPN, what's the sub-address family, unicast in this case, then what's the particular route distinguisher, or what's the particular VRF. This is how we're going to check an individual customers table for BGP. Likewise, if we had VRFs configured, we would say show route, what's the VRF, then inside in the VRF, what's the AFI and what's the SAFI. So show route VRF all IPv4 multicast. This would be for like our VPN multicast routing inside the layer 3 VPNs. So this does take a little bit getting used to, but once you get familiar with it, it makes a little bit more sense how the structure is listed. Okay, the other thing next that is a major difference is how the configs are committed and then how they are saved locally on the box. So in regular iOS, normally you just have two configs. You have your running config and you have your startup config. In the case of XR, there's no difference between the running config and the startup config. There's only the config. It's whatever the active configuration is. But every time you do a commit, as a protection mechanism, the router is going to save all of those individual differences, or basically config diffs or commit diffs for you. So if you say show config commit, I can list what are the different changes that have been made. So this is going to go back quite a while. Where they have individual numbers that correspond to them. You can also give them a label, which is like just a description that you want to use. So I could say, like, set the label to BGP enabled. So then I know if something is wrong and I need to remove that config, I can roll back to whatever the one is previous to that. So if we look at on XR1, the previous changes I made were like to put CDP on. That was one commit. The next commit was to add that user. Then I added IPv4 addresses and committed. So each of these are going to be listed individually. So if I were to say show config commit, show me the last show config commit changes, show me the last 3 changes that were made. Now it doesn't list them individually of these 3, which happened during which commit. If you wanted to do that, you have to list the specific identifier. Or I could say, show me the changes that happened since whatever that particular number is.
And you said you could actually give those things names?
Yeah, when you, so let's make a minor change. Let's like add a loopback address. Let's say the address is 1111/32. When I commit, I could say that the label is loopback. So now when I show config commit list, that was my loopback. So now if I want to roll that back, I can use the description as opposed to the number. Okay, but it's automatically going to do this for you. You don't have to do anything else in order for it to keep the backups of the config. Commit label. Commit label and then whatever the name was. In regular iOS, you can do this, but it's under a separate feature. So if we go to the regular iOS documentation, this is going to be under, I want to say, network management. No. Configuration, replace, and rollback. This is the, and let's just look at their example. This is the archive config command. So you can do this in regular iOS. Every time you make a change, every time you write the config, it's going to save it in the archive, and then you can roll those individual changes back. Okay, this is also useful if you want to do command accounting, but you don't have TACX set up. So every time the user makes changes, if I want to keep a list of what are those actual changes that they're making, that's what the archive is going to do. So let's look at this, like, let's say like on router 1. If I were to say turn the archive on, and I want to do the archive for the config changes.
Can you place the label on that one as well?
I'm not 100% sure. So let's see, I want to say notify syslog. That would generate a log message every time someone makes a change. And then, let's see, record. No. Logging. Enable.
What's the maximum?
I'm sorry, the maximum.
What's the maximum absolute amount?
I think it's going to just depend on the platform. So default length is 100. I'm assuming this means 100 entries, not like 100 bytes or 100 lines. So now, when I exit, assuming that logging is on, you can see it generated a syslog message that my user, which I'm on the console, it made this particular change. So you can do it now. You can say archive config. Let's see. Configure replace. Actually, that's what it's going to do it. So this is going to allow you to roll back based on whatever changes that you made. So you can do it. It's not as intuitive as XR's is, because XR does this automatically. Every time that you make a commit, it's going to show up in the commit list. And then you can, like I said, you can show these individually. You could show the combinations of them. Or if you were to accidentally say commit replace, which deletes everything because I didn't make any changes, I could now say roll back my config, the last one commit. Okay, so this always undoes whatever the last change that you made is. Okay, the other thing that's useful is that if you're making a change live outside of a change control window, that you could say to commit the config, but then to commit confirmed. And how many minutes do I have, or seconds, like let's say 180 seconds, that after I make the commit, so let's say I create like loopback 1. Commit, confirm, 30. You are exiting after. Okay, I need to stay in global config now. So what we should see is that in 30 seconds, it's going to say, were your changes okay? If not, if you don't answer me, then I'm going to roll back the config. So the idea behind this is that if I make the change and then I lock myself out with the new change, it's automatically going to revert back to whatever the one that I had before. Okay, in iOS, kind of the best thing that you can do for this is just say like reload in 5. If I screw it up, then just reboot the box and.
I don't know what happened.
Yeah, I don't know what happened. Or you could say test crash. Make it look like it wasn't your fault that the router reloaded. So let's say it says your changes. There's a trial confirm. So show run. Let's see if it has the loopback. So it removed it. It automatically rolled it back because I didn't say that I wanted to confirm the commit. So that's kind of a nice feature about just the general interface of XR. Some of the other things that are different is that when you run the different show commands, there's different Linux utilities like tail or egrep that you could use for searching and doing regular expression work. Some of these, if I were to say like show run include IP address, or let's say IPv4 address. In this particular version, it doesn't allow you to do multiple pipes. If I were to say like show run include IP address or interface, it doesn't support this. So you would have to put it through grep and then use the regex syntax for that. I'm not really that great with Linux syntax, but you can do it here. So if you were to say show run and then use the utility grep. So this would be basically the same as saying show run. No, I need to say then expression IPv4 address. So this is the same as saying show run include, because I didn't add a regular expression here. But what is also nice about this is that assuming when we show install active, and hopefully they would do this for you in the exam, hopefully the documentation is installed. So you can have man pages, man command, let's say utility egrep. And let's see if they have an example at the end. So as you can see, you can get really, really complex with this. It's really useful when your configs are really large, like if this is a PE router that is servicing literally hundreds of customers. You may have crazy BGP and crazy VRF config that just saying show run is going to take way too long to try to parse through whatever you're trying to look for. In our case, within the scope of the lab exam, the config is not going to get that big, so you don't necessarily need to use these. But if you're already good with Unix and Linux syntax, then a lot of these utilities are already there. This type of stuff is going to be documented under. If we go to, so let me start back at the main documentation page. So let's say products iOS, iOS XR, config guides. We're running 3.9. This is going to be under, I want to say, system monitoring. Or system management, I should say. So this one, upgrading, that's going to be, no, that's 3.8. Let me go to 3.9. But you can see there's not as many topic domains as compared to regular iOS. So before you get to the lab, just open all of these in different tabs and then click around them to see what particular topics are located where. Most of them are pretty self-explanatory, like routing is obviously going to be IGP, BGP stuff. But then, like under MPLS, this is just where LDP and traffic engineering are. The things that are like L2, L3 VPN, that's going to be under virtual private networks. Okay, questions up to this point? Okay, let's see. Now, another thing that it is going to help you with when you go to commit the config is that if you make an error, let's say that we configure loopback 2 has the address 1111/32. I already have another interface that has that configured. This one, actually, this is an exception. This allowed me to overwrite it. But let's say it's like a blatant syntax error. Or we could do that. Most of them, and you guys are going to be seeing a lot of commit fails this week as I'm going through this. So we'll have plenty of examples of when I'm screwing up the syntax here. But let's say like this. So let's turn BGP on, and let's say like for a neighbor, 10.0.0.2, address family, IPv4 unicast. It should tell me here that I didn't actually enable IPv6 or IPv4 unicast routing under the BGP process first. So now when we say show config fail, it tells you what the specific error message is. Sometimes these are not very descriptive, where it just says that your commit did not work. But most of the time, it's going to tell you what the actual problem is. So for this neighbor, I tried to run this command, but the address family has not been initialized. This means that globally under the BGP process, I needed to turn address family IPv4 unicast on. What you could also do is to say commit best effort, which says take the portions of my changes that were not errors and put those into the config. Then the ones that got rejected, just leave those out, and those are going to go under the show config fail. So this was rejected, but it should have put BGP. It should have turned BGP on, and it should have at least specified the neighbor. So this is useful when you look at show config. If you have tons and tons of changes, you want to apply some of those, but then go back and fix the problems afterwards. You don't have to completely abort, which says don't commit my changes, and then start from scratch. Okay, this is also going to be useful if you're doing, let's say, like L3 VPN config on both of the XRs. You can piece by piece put your config together on one of them. Like let's say we have a VRF named A that has address family IPv4 unicast with the import route target of 101, the export route target of 102. So whatever my policy is, once I'm done with this, I can show config, and then basically copy this whole thing out, make whatever changes I need for the other XR, like in Notepad, and then apply that all at once. But again, if you don't want to make the changes, you can just abort, and then that's going to go back to exec. So like I said, as we go through the different features, we're going to go through the comparisons of all of the configs, like how do we configure OSPF on regular iOS versus XR, IS to IS, BGP. But just as kind of a general overview, the things you have to remember is that every change that you make, you have to commit. If you want to remove that, then you can roll back the changes. And then when you're looking at especially when you're looking at the routing table, because if you're looking at like a VRF table versus the global table, it can get very frustrating when you're trying to figure out like why is this route not showing up, and it's because you're looking at the wrong table. Like I'm looking at this particular customer, not the global table, or vice versa. Okay, the same would be true with other verifications. Like if I do a ping and I say ping 10.0.0.2, that's talking about the global table as opposed to whatever particular virtual routing and forwarding instance like would be for an individual customer. Questions? Yes. Pretty much no. There are going to be, so the question was, do you need to enable default features like Ceph or like IP routing? Most of the time when you turn a feature on, it's going to do whatever else behind the scenes that you need to do that. There are going to be some exceptions for that. One of them would be like if we're doing MPLS traffic engineering, you also need to turn LDP on. Even if you're not using LDP for labeling, you can end up in some weird situations where your config looks good, but then the router doesn't actually forward traffic. And those are going to be kind of more minor caveats that we're going to talk about when we get to those particular features.